Now that we have learned that the pressure is the same at any 2 points at the same level in the liquid or in the fluid, regardless of the shape of the container. As we have learned that the pressure in a fluid increases with depth due to the weight of the fluid above the point of interest. So in a completely enclosed fluid may be subjected to an additional pressure by the application of external force. As we have seen in the image, we have two interconnected cylindrical chambers with different diameters and together with a connecting tube, which is completely filled with a liquid. The larger the chamber is sealed at the top with a cap, while the smaller one is pitted with a movable piston. So the important picture here is this. The pressure that adds at the piston due to the depth of the liquid at any point, whether the point is in the smaller chamber, the connecting tube, or the larger chamber. Therefore, if the applied pressure at the smaller chamber is increased or decreased, the pressure at any other point within the confined liquid changes correspondingly. So this behavior is described by Pascal's law. It was discovered or recognized by the French scientist named Blaise Pascal. It states that if the pressure is applied to a non-flowing fluid in a container, then that pressure is transmitted equally in all directions within the container. So for simpler explanation, let's consider this schematic diagram of a hydraulic lift. So initially, we have the fluid at a stable position, which is at the same level, and it is completely sealed with a cup. So obviously, we have different diameter. So if we apply force or pressure at a smaller cup all throughout the fluid, we'll also experience the addition of pressure. So initially, we have same pressure at the same level, but and when we apply additional pressure at a smaller cup or even in larger cup, it will experience an equally amount of pressure. Thus, the pressure at point 1 and point 2 will be equal. That will arrive in this equation that the pressure at P1 and P2 is equal, or point 1 at point 2 is equal. Thus, we have the ratio of force and area at point 1 is equal at the ratio of point 2 of the force and area. Now let's have an example problem. In the hydraulic car lift, as shown in the picture, the input piston on the left has a radius of 0.0120 meter and a negligible weight. The output plunger on the right has a radius of 0.150 meter. The combined weight of the car and the plunger is 20,500 Newton. Since the output force has a magnitude of 20,500 Newton, it supports the car. Suppose that the bottom surface of the piston and the plunger are at the same level so that the height is equal to 0 meter in part B of the figure. What is the magnitude of force 1 of the input force needed so that the force 2, 20,500 is detected? So let's have our given values. So we're looking for F1, and the radius at point 1 is equal to 0.0120 meter. At point 2, the combined weight of the car and the flanger is equal to 20,500 Newton, and the radius of the larger chamber is equal to 0.150 meter. Based on Pascal law, the pressure at point 1 is equal to the pressure at point 2, and pressure is equal to force 1 over the area. Therefore, F1 is equal to F2 times A1 over A2. So the given value of F2 is 20,500 Newton. And using the formula for the area of circle, the area of point 1 is pi times the radius 0.0120 meter squared all over the area of the second point. Pi times 0.150 meter squared. And calculating this one, we will have the value of F1 is equal to 131 Newton. Okay, so now let's have your example problem. Let's have your test your understanding problem. Try to solve this one with the same figure, and this time you have to look for F1 at the height of 1.10 meter as shown in the figure.